That's why I feel like I've heard a lot about in like my, limited research about sickle cell, because I feel like that's a good one to start at, that it can make a big difference right away. Is that why that is like used as an example a lot?
Yeah, I would say, it's also, it's the first one that's come into clinical trials. And there are
Okay.
several,
Right. Okay.
yeah, there are several different approaches to fixing that particular gene. So I think also because, it's a relatively straightforward repair. It's a single base. It is actually considered a rare disease, but it's like the most common rare disease. So, at least in the United States, there's more than, 100,000 patients in the United States. And another important thing to consider is that, not only patients do they get this life-changing cure, if you will, but, they don't, sickle cell patients often have to go in to get blood transfusions and things like this. So they have to be on medication. So it eliminates all of that. And like I said, I think it will be a real big life-changing cure. And, CRISPR now is also being used for other purposes. So we can use CRISPR to engineer, for example, our own immune cells to target cancer. And so this is another way that CRISPR is being used right now. And so, your immune system is capable of destroying cancer cells in your body. They just have to be told where to go and that the cancer cell is foreign and bad. So, I think, I imagine CRISPR is going to be used more to try to treat, these types of diseases of the blood.
Cancer, man. Cancer is like that's the one. It's the one that most people are affected by. That's deadly. Yeah. Like that's the number one you want to go after, I would think. And like, again, like, so the sickle cell thing is, you said it's in clinical trials. Like that basically means like it's not available to the masses yet. Like we're early. Yeah. Like if someone has it right now and they're 17 and they're like, I got to get this fixed. Like they might be a little frustrated at the fact that it's like they can't go to the store or the doctor and get it right now.
Yeah. We're a couple of years away before these therapies, they have to go through all the safety checks.
Okay. So once it does go through the safety checks and someone, well, I guess you would kind of be able to identify that at a very young age, but they could just basically go to the doctor like they could for a flu vaccine or a checkup, and just like, what's the process like? Like, it's like a needle or like,
yeah, it's actually for the sickle one, for the blood. It's a little bit more involved. So, I imagine in the future, we're going to start to see more and more clinical trials utilizing the CRISPR technology. For the cancer patients, it's actually more of an infusion into the blood. For somebody, if they're trying to correct a type of blindness in the eye, it's more of like injections into the eye.
Okay.
For something,
so it's like in the physical part of like where it affects the body.
Yeah, it can be. Really, and I would say that the future, kind of like future generations of this technology, will actually be more of what we call in vivo, where they will just do an injection, and then the cell, they will have some molecules with the CRISPR reagents technology in them, and they will just go directly to where they need to go in the body. But as it
would be like a pill or something?
No, I would say more like an injection.
Okay, injection, but then the injection would just like spread to where it needs to go.
Yeah, that's really kind of the future. And we're still not quite there in terms of the technology. We need to direct it to the specific place.
Okay.
So for the sickle cell one, just going back to your question, it's a little more involved right now. That actually would require a hospitalization, because what they'll need to do is to go in, and they actually will need to give the patient some medicine, actually kind of like a chemotherapy, to remove a lot of the of kind of the bad stem cells, if you will.
Okay.
And they will repopulate on their own. And then, inject the ones that have been CRISPR edited to give them a better chance to persist in the future. So that kind of a treatment for sickle cell, when we think about it, it's in clinical trials now. There's some new clinical trials that are starting, this year and next year, from, different companies and different academic institutions. We're probably, 3 or 4 years away from this becoming something that a patient with sickle cell can go to the doctor and say,
it's not too far though. It's not too far.
Yeah, it's not too far away. And, it's a gene therapy. So, it's a bit involved, and, a lot of decisions have to be made by the patient, but it's pretty exciting to think about.